Dear colleagues, I am happy to present my work on the symposium. Antifungal azoles is a class of pharmaceutical or drug-like compounds possessing an azole-based pharmacophore and possessing ability to inhibit fungal growth. The examples you can see on the slide, notably recent approval of oteseconazole and publication of WHO fungal priority pathogen list can significantly reinforce research in the field. Molecular mechanism of action of such compounds is related with inhibition of CYP51 or cytochrome P450 40-alpha dimethylase, which catalyzes conversion of lanosterol to its 14-demethylated metabolite, and which when further processed in ergosterol. Ergosterol is necessary for many functions and especially for building of membranes of fungi, yeast, and also trypanosoma. Azole-like compounds inhibit the class of enzyme, forming binding in the active site together with a special coordination bond of its azole ring with iron-iron of the heme groups of such enzymes. Also, example you can see on the slide. Recently, pioneering work from Israel group of Friedman has been published describing fluorescent derivatives of antifungal azoles based on fluconazole-like scaffold. And analyzing their work, we find the gap related with design, synthesis, and testing of ketoconazole or itraconazole-like fluorescent probes. So the task of the research was to design a structure and a synthetic route for ketoconazole-like fluorescent Nbd derivatives to synthesize the compound and to confirm the desired compound is obtained, and perform, of course, in silico inverse virtual screening using docking method to reveal potential targets of the compounds among cytochromes P450. A few words about the design. As you can see from itraconazole and ketoconazole structures, they have unique imidazole-based pharmacophore group taken together piperazine ring, dichlorobenzene, etc. And also in itraconazole structure, we can see two-ring substituent connected to its piperazine ring. Thus, we decided that we have a so-called verified safety space to insert some fluorophore instead of acetyl or this complex group in the structures of with non-fluorescent compounds to gain the structure we would like to synthesize. Chosen among fluorophore, we preferred Nbd because of our experience and two-ring size of the pharmacophore. Okay, taken together, we have proposed a synthetic route from two steps, including hydrolytic deacetylation of non-pharmaceutical and thus Nbd aromatic substitution of piperazine ring in the intermediate. Confirming of receiving of desired structure was done using H1 NMR analysis. A part of the spectra is presented on the slide, confirming proper ratio for Nbd and ketoconazole-based protons. Also, it was found that the compounds have affordable fluorescence only in a very strong acidic solution, and it was in accordance, and it is in accordance with published data for other system like we have. To perform high throughput virtual screening, we use docking software Autodock Winner with the indicated parameters and the set of structures from PDB database, totally 86 structures, all with ketoconazole, etri, or posaconazole in the active sites. For data processing, we used MGL tools via Discovery Studio to gain pictures, and original software FeedDoc we have created in our lab, which allowed to organize, run, and analyze results very efficiently. Okay, just a few results from the virtual screening. They include localization close to heme of CYP51 of trypanosoma with good energy and good position, imidazole ring to iron atom of heme, and the similar results were received for also structure of human CYP3A4 enzyme, and surprisingly to NO synthetase from fusarium, as you can see from the slide. Summary of our work can be seen on the slide. New ketoconazole-based fluorescent derivative was designed, and quite simple two-step synthetic route from available chemicals was proposed and tested. The product was confirmed, and docking-based virtual screening has helped to find that cytochrome P450 CYP51 from trypanosoma, as well as human CYP3A4 and NO synthase from fusarium, are among most probable targets for the compounds. And of course, further design and silico and in vitro examination of biological properties of the new compound, as well as similarly designed ketoconazole-based fluorescent probes, look very promising for us. Thank you for allowing me to present my results on this prestigious event. I would like also say a few words of thanks to my team and financial organization and all listeners for your attention. Thank you very much.
Thank you very much. Vladimir, you can run the discussion.
Okay, so, thank you very much. Okay. Thank you very much. So if anybody have some questions to talker, to speaker, I do not see any questions in the chat.
Okay, maybe later, who knows.
Okay, thank you very much.
Good luck.
So please delete your message, your presentation, and share it.
Okay.
The next speaker.
Vladimir, stop, please. We have to follow the time schedule. So we have about 8 minutes, 7 minutes for discussion, general discussion. Maybe some points for some other speakers, etc.
Okay. Let us discuss. Who
Yeah.
would like to
So
ask
maybe
some
you a
questions?
little bit comment on the questions and answers that you wrote in the chat regarding the relevance of biological
Okay. I
target.
wrote, in fact, I wrote all the replies. So now I will read it.
Okay, but I can ask Yaroslav concerning further validation, because you told about docking. You did this is like usually considered the first step of validation, at least followed by molecular dynamics. What do you plan to do further, please?
Oh, okay. Thank you for the question. It is a really important thing. Some of them I cannot discuss because of our plans to publish this result together with some others in an article. But of course, we will be happy to discuss in detail some molecular dynamics test, because we have no ability to do this in our lab, certainly because of we have no powerful computer units.
Yaroslav, also there is a question in the chat.
Yeah,
What was the coordinate for the grid box?
Oh, thank you. Coordinate have been estimated automatically as the geometric centers of proteinic structure we use. For this, I used this original software FeedDoc, which is calculate geometric center of whole structures or specific groups of proteins we would like to test in silico.
Additional question in the chat. I want to know if during the NMR analysis, if you did run for 13C data.
Probably not, because we did only this 1H NMR, and we are going to do 13C in NMR, not more. No special expensive, time expensive and money expensive NMR seems to be not necessary, because we have enough data to confirm purity and the structure we have.